Right, so the way this works is each speaker gets exactly 5 minutes to talk. They can finish a little bit earlier if they want. We've got a countdown timer here. It's a little bit difficult to see from everywhere in the room, but hopefully we'll get by. What we're going to do when we get to 20 seconds left, start clapping with your fingers. That'll just give the speaker got 20 seconds to go. Once we get to 10 seconds left, start tapping on the table. A little bit louder. And as soon as we hit 5 minutes, round of applause, you're out of here. So that if you've been to any of the normal Postgres community events before, this one's going to be a little bit different from the way we do lightning talks there, because we have an awesome prize. A Phantom 3 drone, a camera that looks, I could have some fun with that. Now obviously we've got to pick a winner, so we've got Ed here. Can you give us a quick introduction? Everybody know who you are?
Yeah, I'm Ed. I work for Dave.
I'm Eric. I organize New York's database meetup.
So Álvaro, we're going to be talking about ToroDB.
Oh, I know him. Not by face, but by name.
Alright, so today, this Postgres conference, we're going to talk about how to help these poor souls that are running MongoDB. So they say no SQL, and now they want SQL. So what I'm going to talk about is how to bring all this NoSQL data to the SQL world and help this, again, poor souls to do their things. So all your MongoDB data are belong to SQL. Well, what do Stripe and Buffer have in common? They're successful companies, they're web scale, they use MongoDB for every transactional operation. What they also have in common is that they give them to an ETL to bring the data to Postgres to do the analytics. And why do you do that? It's because the analytics in MongoDB, it's a pain in the ass. It really sucks. Sorry for the language, it's the real truth. I'm going to show it to you. So basically, doing a basic aggregated query in MongoDB, just finding some stuff over a tiny data set. With 100 gigabytes, it takes almost 20 minutes just to find this information. So can you imagine doing analytics in MongoDB? Really, I can't. So we tried to find out what is the reason for this. And the main reason is that NoSQL lets you throw any data into the database. But what is that? That's a count. How do you make sense out of that data? If you throw anything, it cannot be ordered. It really works internally. By every time you do an aggregate query, it goes key by key, value by value, doing a lot of tests. It has to iterate the whole database all the time. To demonstrate this, we have done another test. What if we try to bring the relational database and iterate the comparison? So the first thing that we did is basically compare the I/O required to perform an aggregate query. In MongoDB, in Postgres, and Postgres with columnar store, and in C-store. These are the results. It's pretty amazing. Basically, in MongoDB, you're reading the whole database all the time to answer the query. This is a pain. What about query performance? Well, if we compare this query on MongoDB and the same query running on Postgres with purely relational tables, the results are pretty surprising. The green bar is MongoDB. This tiny thing here you may or may not see, it's a Postgres query. This query type is less than better. So in version, you can see that basically the comparison is really shameful. So it's really great if we could bring all this MongoDB data into a relational database like Postgres to perform analytics and help these poor souls. If we take it to the extreme, because MongoDB scans all the data, and in Postgres we might scan only small tables for frequently used data, then the difference can be almost infinite. It could be 2,000 times faster queries in MongoDB compared to Postgres. So hopefully this time you're all sold and you say, yes, give me SQL, let's bring all your MongoDB data into SQL. The problem is, we need to decide the schema. After all, they don't, and we have to. And what about HA? What about real time? We don't want to do ETL. Many people want to do analytics real time. Well, not all hope is lost. Fortunately, we have something called ToroDB, which is open source software, which basically works as a NoSQL to relational transformation process. So it takes JSON documents and it will automatically infer the schema, automatically create the tables, automatically create the columns, just as if your DBA were studying the schema, and replicate in real time because it listens to the replication protocol and bring all your data to your tables to Postgres. It is effectively a MongoDB replica. It works as a secondary node, hooks to a MongoDB cluster, starts replicating data, and all the data will end up being on relational tables, pure relational tables, foreign keys, all that stuff, you know, with nice names and everything you need to perform queries now in SQL. There's basically, this is the most important thing for me, this brings us a lot of opportunity. So we can reach further our Postgres world, Postgres ecosystem, and get into the business of helping MongoDB people. So this is effectively a great BI connector. MongoDB has a proprietary BI connector, which we can now compete with. First of all, this is open source, it's 100 times faster, and it is not proprietary. It can also help us do live migrations from MongoDB to Postgres. You know, if they basically want to come back and see the light and go out of the dark side, we can help them do that. And of course, it can also help us integrate between heterogeneous platforms containing both non-relational and relational data and create applications using both SQL and MongoDB APIs. That's all. Thank you very much. We'll be coming to GitHub soon.
Thank you, Álvaro. Any comments from the judges?
Yes, definitely. Okay, so I'm knocking a couple points off for using Percona Live slides without, and you could at least change the bottom footer. Other than that, you're very funny, and on top of that, you demoed a large, broad body of knowledge in a really short time very well.
Yeah, agreed on the Percona Live. You're excused from the event. But other than that, great. You simplified it, and your use of graphics to demonstrate the points was incredibly helpful to get the concept.
I don't know what the guys were doing that slide.
Okay, next up, Patrick King.
Hi, my name is Patrick King. I work at Yelp. I'm at Mr. Mustache on Twitter if you want to yell at me in real time. So Yelp's mission is to connect local businesses with users. Marketing slide, they maybe put that in there. So we're going to talk about using, having a messaging queue with Postgres. So any kind of messaging queue, the one we're going to talk about is used to support push notifications. So it's a wide-ish table. This is an example data set, and so it has booleans like sent, has been opened by the user, has been deleted by the user, or it's been marked as read without ever being opened. We write a row once, we read it once, and then we update it 4 or 5 times. Each row, on average, will stick around in the database for about 3 months. And this is just, an academic example of what it will be. Here's what the table looks like. It's super exciting. Not really. So here's the notification row lifecycle. It is inserted by a batch job. The second batch job will eventually scoop up this row, ship it to the user on their phone. It will update sent as marked as true. And then when the user gets it, they're either going to read the message, they're going to delete it without ever having read it, they're going to mark it as read without ever opening it in the app. And then it is eventually deleted. Like I said, select once, update 4 times. This is just auto vacuum can't keep up. Like it's just not going to happen with the tables. It's just update heavy. The table in this example, live data set was about 10 gigs. Table was 131 on disk. PD Repack to the rescue. It is an amazing utility that'll compact all of your table data. Basically what it does with some triggers, it'll take an exclusive block, write some triggers to your master, to your primary table. It'll then go ahead and do a create table as select, and it'll pull all of the table data out, only the live data. And it's an incredible utility. You can run it on a live system, no problem. Great, the table is now the correct size for mostly performant. Problem is it's still getting bloated, like there's still problem queries. We have to delete data out of this table eventually. This is a queue after all. So when the two times we delete data is when notification gets too old, when the original batch job is going to go ahead and run a TTL time that's usually about 3 months. Or when the user deletes the notification from their inbox. So if we look at this table, there's 31 million rows in it, and then we look at our delete statement, there's 3 million rows that need to be deleted. This is about a week's worth of deletion traffic to do. So every week we're deleting 10% of the table. It's kind of untenable. Yeah, during heavy usage periods, this table will get up to 60 million rows, and about 6 million will need to be deleted on a weekly basis. How can we safely and quickly remove 10% of the rows? PG repack. We're already using it. Like I said, it does create table as select where to generate the new table. Why don't we just flip the delete statement around and add that to the create table as select? So we're getting all the rows that are not deleted, and the expire time is greater than now instead of less than now. Where do we find the statement though? Well, I spent some time digging through the source code and found in the reorg schema, there's a create table statement for every single table name in the database. This, just change it. Like, sure, let's experiment on a live system. This is fine. So I found this, go digging, but oh no, it's a view. It's not a table. Well, we can cheat, and we just make it a table by selecting from this whole thing, and then we just rewrite the specific row we care about. Run it. Run PG repack like we normally would. All of the rows that we don't think should be there anymore are now gone. The only data that we care about is in the live table. Takeaway, like this process is super happy, like we're modifying tables on disk for an extension. I created a pull request to do this automatically, it's still open. This is just one use case, but PG repack is basically the best way to bulk delete data out of your database, just bar none. Thank you.
Very much. Judges,
Okay.
would anyone know what I mean if I said Simon?
Great, Patrick. Great energy. Good job on that. I think you did a good job describing the problem and then explaining the solution to the problem. I wanted a little more, I'm a math guy, so the dollars and cents matter, so I was still trying to figure out, okay, what is this, what did I save?
Gotcha.
Okay, so first I want to commend you because you tried to cover a 108 slide deck in a 5-minute lightning talk, and yes, I did notice your slide count on the bottom.
Oh no, this is for all the talks. That's just not me.
Okay.
This is a compression of a 35-minute talk into 5 minutes though.
Okay, unfortunately, I have to say that the compression lost a lot of the fundamentals, so it was pretty hard to follow. I got what you're saying; it's a cool idea, but I got lost a few times in 5 minutes. So.
All right. Thanks.
We'll reset and go.
All right. Hi, I'm Misch. All right. Lightning talk for me. We're going to be talking about putting your Postgres database directory on NFS. Usually I expect some twitching right about now. I don't see too much twitching, but this is your opportunity to twitch if you want to do that. Sorry about my missing the microphone too. But there are good reasons to do this, or at least mediocre reasons to do this. Cases where I'm doing this is I was setting up a build farm member on a MIPS box. It looks like this. It's called an Edge Router Pro. It's kind of popular among people that are trying to work on MIPS because MIPS systems these days consist of home routers with 16 megs of RAM, development boards that cost $10,000 or more, and these things, which have 2 gigs of RAM and cost a couple $100. But they don't have much storage space. They just have some flash storage, a couple gigabytes. So NFS is the way the owner of this particular system set it up to have home directories. So that's what I had to work with. By the way, these systems are part of the So this is set up to use NFS 4.0 as to map home directories. And when I first ran the PostgreSQL test suites on this, it mostly worked, but about, say, 30% of the time, the ECPG test suite would fail. It wasn't exactly clear why ECPG was special. It turned out it was that the ECPG test suite is one of the few that does significant concurrency among our test suites. And it was running into a case where we're attempting to create a file from two different Postgres backends at the same time. You'd think this would be kind of common in our test suite, or you might think that, but it's actually not. So I was getting an e-access error during the test suite for ECPG. Dug into this a little bit. It turns out NFS has an interesting implementation of some of the POSIX primitives. The OEXCL option to the open system call, which we use in a lot of places in Postgres, designed to make sure that two processes don't create the same file at the same time. The way this is implemented in NFS v4 is actually for each client to send a random 32-byte verifier value saying, I'm the one who created this file. And then after it creates it, it checks and sees whether the file has the same value that it sent. The problem is the storage space for that little cookie verifier value takes the same storage used for the file mode. So you can't store a file mode at the same time as you have this verifier value. So we can't decide whether the file is world writable, world readable, or readable to node. In fact, the way it's implemented in Linux is that it's readable to no one until that process is completed. So if another process tries to open the file at the same time, even if it's the same user that created the process, you can't open it. Turns out this is a protocol level limitation, and it's fixed in NFS 4.1. So I switched the box to NFS 4.1 after begging the administrator nicely, and that does fix this particular problem. However, pretty soon after that, I was finding that vacuum was able to completely freeze up the mount point, the NFS mount points, so that nobody could use it. Didn't get to the bottom of why that was happening, but I think the bottom line here is you probably shouldn't use NFS for your Postgres database if you have any other choice. Because I think it's possible to set up NFS to run well on Postgres. I just don't think I'm smart enough to do it. And I would recommend that if you value your time, try not to become smart enough to do it. That's all.
Nice.
Who's actually run on NFS and running the programs? There's got to be more than a few people here.
Yes. Nice job. No, I like the way you kind of juxtaposed the beginning with the end. I thought that was very clever. I also like the simplicity of the slides. You relied on your expertise, and I focused on you because of it. Good job.
I very much liked your conversational storytelling style. I think that works really well in a lightning talk format. You were easy to understand. You explained it well, and the best part was the counterintuitive end moral.
So I'm going to stick with the topic I started on yesterday, right?
Hang on a second. One technical issue. Go.
All right. So I'm gonna start on the topic that I started yesterday, which is Node. A lot of people who I know here think I'm a database guy. I'm actually not. I'm actually been doing application development for a very long time. Okay, databases to me is just a facility to store my data in. And fortunately, I use the best database out there, which is Postgres Plus Advanced Server. I am going to pass it to the judges, by the way. Okay, I've been doing most of my Postgres work over the last 8 years on PPAS. So I'm going to actually continue on the topic of Node. And my goal in the next 4 minutes and 10 seconds is to teach the CEO of EnterpriseDB why he should be out there talking to all his clients about building applications with Node, right? And Node, and my favorite framework, which is Adonis and Lucid. First and foremost, anyone who's done application development, right, or anyone who has DBA, who's a DBA who has application developers working for him, know that the biggest pain is when they first go out and try to build a schema. Let me build an application schema that is actually going to work. How many people here have that problem? Right? You have developers who are out there trying to be database people. They can't. I've got clients who've got thousands of developers who write lousy database schemas and that change every single day. If you use Node, you have a nice little facility that's called ACE that allows you to do one very important thing. Right? It lets you build migrations. And what's a migration? We're going to talk about it in a minute. First and foremost, ACE lets you do things like build your database, reset your database, seed your database. Your developers don't have to ever think about building scripts for this stuff. It does it for you. Okay? The most important thing it does is it builds migrations. It allows you to run migrations. What's a migration? Migration is this nice little handy thing that is a developer-like script. So it's right in their wheelhouse, right? That lets them do all sorts of things. Build tables with sequences. Oh my God, they're actually putting sequences on their tables for unique identifiers. They never ever have to know that they're building a sequence. They just say, hey, this table increments on a regular basis. Anytime I do an insert, it increments. Unique identifier for my table. It actually puts timestamps on things by literally just saying, give me a timestamp. And not just one timestamp, but when it was created and when it was updated. Okay? And then it does another kind of nice thing that I like, which is soft deletes. How many people here have customer data that their developers think that it's okay to delete? Right? With a very simple statement, you can say, hey, this table will soft delete. Okay? And the best thing about it is that whatever goes in can also come out. You can actually build your script so it says, here's how you create the table, here's how you back it out. So when you make changes, right, as we will in the next slide, I'm going to add a foreign key. A developer will never know what a foreign key is. Okay? But I'm going to go ahead and add a foreign key. And as you can see, in my up statement, I build my foreign key. And oh my God, I ran it, and guess what? I'm running into constraints all over the place because I didn't do it right the first time. I can back it out with a down and literally just run ACE and do a step back. And it will basically back out the change. The nice thing about this is that once all these scripts are built, right, I can run it anywhere. I can take it from my developer laptop into my acceptance environment, into my production environment, and you run the migrations, and all the tables get created, all the sequences get created, and a developer never has to write a single line of code. The other nice thing about it, I'll step back, is you see these constraints, these little functions I have here, right? As an application architect, I can build these things for them the way I want my application built. Okay? So my developer never needs to understand what's going on in the database, and we can give them the best database schema and the best application possible. That's it.
Well, if you're trying to butter up the judges, you hit the right topic, because migrations is something I've been an advocate of ever since it was introduced in both Cake PHP and Rails. So I've built not dozens, but about a dozen migration systems myself. So I think you did an amazing job explaining what migrations are and how to use ACE to do it in a very short time.
All right, I like the thesis and the detail. I'm not sure you really made me smart enough to be able to sell this to customers. And I'm going to go off script a little bit. I actually remember that yesterday you said to me that I was old. So all your shameless pandering to the judges didn't offset that.
Okay, next up, Ivan.
Yeah. Hey guys. I'm going to talk to you guys about machine learning inside the database. So in database, machine learning. And we're going to leverage a library that's freely open source and available called Apache Madlib that runs on top of the latest version of Postgres. It also runs on top of Pivotal Green Plum, and it runs on top of Apache Hawk. And what this is a library that gives you user-defined functions that you can use to do machine learning on your data in your database for analytics. So the first question, which I learned relatively recently, is kind of what is machine learning really, right? And I want to share that with anybody who doesn't know. And firstly, when you look at machine learning, there's two kinds of machine learning. There's supervised learning and unsupervised learning. So supervised machine learning means that essentially you've got a bunch of known data. For example, transactions like tax payments. And then you've got known fraudulent cases. And these are marked in the table as fraud. And then you run a bunch of algorithms and you get back an output that says, okay, these things correlate with fraud and these don't correlate with fraud. So that's how the computer can learn to recognize an outcome. Unsupervised machine learning is basically when you don't have any known outcome and you're just going to go and group data into categories and say, okay, I want to download all the blogs on the internet and I want to learn about them. What are the different topics that people on the internet are talking about in blogs? So that's supervised and unsupervised. So hopefully that helps you to have conversations with other people in the future. Now I want to actually give you a demo. So for the demo, so first of all, just FYI, what I did was just started up a machine here on AWS based on an image, and then SSH off for the Wi-Fi, so hopefully our Wi-Fi cooperates. And then here's the demo. So we already talked about the difference between supervised and unsupervised. I already showed you the website of where the library is. So now with one hand, I'm going to copy and paste this. Okay? So here's this really contrived example, right? In the real world, you're going to have millions of rows, and it's going to be able to figure it all out for you. But I actually just added the rows one by one by faking it. So the rows are, what did I buy in my credit card? How much was it? How far was it from home? What was the category of the product? And was it a fraud or not? So what we got here is I went to Starbucks. So I went to Starbucks for $5, $3, $13, $6, $8, $8, $4. Just one time the Starbucks was 5 miles away. Usually it was 1 mile away. This was my refrigerator, $500 refrigerator, 5 miles from home because it wasn't right at my house. And then it was category 2, vendor, and then $100 for non-fraud thing that I bought 20 miles from home. And then all of a sudden here was $125 of category 4, 490 miles from my home. So the way the library works, it's all just based on data and numbers. It doesn't really, there's no rules. I'm not telling it, okay, put in this number or that number. It's just going to learn on its own, right? Let's see. What I want to now detect is, okay, I want to detect, are these fraud or not? All right, so let's see. I'll skip that part, and again, with my one hand, let's see what I can do. So, SQL, I want to run -f, and I want to train the model. Okay, I'm going to put the mic down. So this is the output, and you can see, and I'm going to show you the SQL in my 25 seconds. So in the output, you can see log of the $5,000, 1,000 miles from home, and the other thing was not fraud. And I got 15 more seconds to show you the SQL. So this is how you train the SQL, one function call, and in 6 seconds, this is how you score the model. Another SQL.
Especially one that uses the Wi-Fi at the conference center. I hope the judges
Okay. Okay, yeah, Ivan. So great setup and explanation. That was very helpful. Definitely you get the high points for most ambitious, and nice live demo. I'm always still looking for a little bit more of the value, like give me the numbers and so on. But good overall.
Wow, that was ambitious. You did go almost over time, but you managed to actually get the final punchline in at the last second, although I'm not sure how clear it was, the end result, like how the actual supervised learning was, but man, 5 minutes, phenomenal job.
All right, thanks.
Hello, I'm Alexander Korotkov, and I'd like to present you one development we are doing in Postgres Professional about JSONB compression. If we take a look at what is JSONB consists of binary, we can see that it consists not most from data itself, but a lot of key names, a lot of headers, etc. Headers also contains a lot of zeros because it has small numbers for large documents, and also key names are repeated in every document, so it's not efficient in space terms, and we can improve it by following dictionary compressions with following features. First, we need to maintain some dictionary of keys, but this dictionary shouldn't be global because different documents collections will have keys, so that should be per column dictionaries. Another thing we can do is to squeeze headers because they contain a lot of zeros. We can compress them using byte compression, and the same we can do with some small numbers because small numbers frequently occurs in JSONB, and they are encoded as numerics, which is not very space efficient. What we did is the same 3 times smaller in this example, and if we compare it with on customer review, that data set, JSONB is first column, the second column is customer review in flat table with array, which is much more compact. It's about 2.5 times more compact, and our compressed JSONB is even less than just flat table because we also have compression for numerics. So the size of this compression is good enough. Currently, we are developing not only JSONB compression but pluggable compression mechanism, so that data types would have custom compression methods which are extendable. Now it's under inner testing for Postgres Professional, but it will be provided to open source with the mailing list. Besides, this is so generic mechanism, quite new. It would be not easy to push through the community, but I think we will eventually do this work, and we will have really compact storage for JSONB in Postgres, dictionary compressed JSONB. Thank you very much.
Who's using JSONB? Probably a few people, yeah. Judges.
Okay, he's off the stage. Well, anyway, so first off, you get extra credit for going through a whole JSONB presentation without mentioning Bison in MongoDB. Nice job. No, actually, though, I said you get an extra credit for not mention for an entire JSONB presentation without mentioning MongoDB's Bison. So nice job. And no, actually, though, there's a lot of market value for what you're explaining, and if this could come out, you said it's in development still, but if you can make it solid, there's a lot of value to that. So nice job.
Thank you very much.
Yeah, Alexander, really nice job. It's very interesting to me. I think the only thing I really wanted, I would use the last minute and a half to talk about customers or users that you've talked to who are interested in the tech, but I'm really interested in that. Nice job.
Thank you very much.
Okay, we've got Samir and Stephen next. Samir from Ashley.
So what we're going to look at is actually a customer use case, which is the customer. We've got a challenge that many of our big enterprises have. We've got too many databases. There's actually 7 standard databases in my organisation, 3 of them are locked down. It's a big problem. We have a challenge of managing the databases, managing the system. And we have a large area. So this is about the size of continental US with a whole lot of water, which is a problem. Lots of different languages, lots of different support teams, local to the business. So what we are looking to do is to work out how we can address this, and the optimal solution is to move the databases onto a single server, look at multi-tenant, and that presents some latency challenges and some other things that really tie to just geography. So this is what the end solution looks to be, but presents some challenges, as I said. So how can we address that? Well, we can duplicate that at one end of our environment, and the other one at the other end of the environment. So Hong Kong and Singapore are our primary data centers. We can look at how we split and segment the databases to make sure that we give every country, every business, the databases and the segregation and some comfort of security that they think they need. And we can look at high availability, resilience, and redundancy. So this is really where we ended up in terms of implementation, in terms of design. The initial product was our corporate website, so a little sensitive, but also not a whole lot of data. We chose Postgres after putting a POC together. There's a whole lot of reasons why: resilience, streaming, high availability, and really one of the things that was very interesting was effectively the ability to manage this across latent WAN, and to be able to move from 2 sites to more than 2 sites. Now, what I'm going to do is I'm going to hand over to Samir to look in detail at the final architecture.
So, in the final architecture that we had was essentially EnterpriseDB Postgres Plus sitting as your multi-tenant database, and each region or each service will have its own database inside there. So that is really very flexible in Postgres Plus, because it allows you to have multiple databases. Of course, that is also possible in PostgreSQL. Use streaming replication to create intra-site resiliency, so we have got redundancy within the site itself. And if the master goes down, we have got failover manager agents. That is what you see as these red dots in each of them, working for us to promote the standby. So if the master goes down, the standby gets promoted and becomes master, fully read-write capable. We have got a PG pool there, which helps us load distribute between master and standby. So since this is a website, there are a lot of reads happening, and PG pool essentially is very critical there, because it can help you load distribute your reads. And if there is a failover happening there and standby gets promoted, that is to quite an extent very transparent to your application, because PG pool automatically detects that there is a new node which has become master, and that node starts acting for reads and writes both. Your application need not change the IP address or anything. And use XDB replication to replicate the data across from one side to other side. And like what Stephen had explained earlier, we had the concept that those geographies which are nearer to Singapore would connect to the data center in Singapore, and those geographies which are nearer to the data center in Hong Kong would connect to that. And it would be a two-way unidirectional replication. So the data set is mutually exclusive for both geographies, and hence we are able to have 2 different replications going on, and we could schedule them as well. So when we are scheduling it, we could schedule it across 12 hours or 24 hours timeline, so that they are not overlapping with each other or not contending with each other. what we got is a fully resilient and available database, available across computers.
Please stand and be judged.
I think you have a good product there, but honestly, I don't think a 5-minute lightning talk did it justice. In particular, there was one point right in the beginning you said, and here's our solution, and the slide was on the screen for less than 3 seconds, and I honestly couldn't look up fast enough to even see it and went on to the next slide. So I think you have something good, I just couldn't follow in that 5-minute talk format.
Okay, I thought you guys did a great job defining the problem. It kind of resonated with me, and I think the way you described the solution, I actually, basically got it. I'm not going to give you extra points for your absolutely fantastic use of EDB, Postgres, and XDB in your solution. I'm not giving you extra points for that awesomeness.
President of Postgres Europe, Magnus Hagander.
That's okay. So hi, as Dave said, I'm Magnus Hagander. I'm here to tell you a short story. It's actually a story about the customer work we did about a year ago, but it's fairly relevant to this location at this time, actually. So as all good stories, we start in a beautiful place somewhere far away. Any guesses? Where is this? I took it off my manager's Facebook page.
Iceland?
Iceland is not that bad of a guess, but it's not correct. It's Norway. So I realized that when you all think of Norway, you think of something like this, because that's really what Norway is to most people. But in our case, we're going to think about this part of Norway. That is the administrative regions of Norway, and we're going to look at the project that was the Norwegian elections last year. Now the voting order is different from here, obviously, but the basic thing is all voting is done on one day. All voting that we not really care about, but there's some pre-voting, but it's mostly there. It's 8 a.m. to 9 p.m. on one day. They use paper ballots, none of these advanced hackable machines that you guys use. It's all counted locally. Then anything that's not perfectly clear is sent centrally and scanned, and then incremental results are posted as soon as the ballot points close throughout the night. Now the thing that we were involved in was running the election administration system, which basically has a few features. It has live information on who can vote, who did vote. It has the batch processing of dealing with these scans results, and it has an output that basically tells you who won the election. It's kind of an important point. This is a locally developed application that was, to the previous election, it was built by somebody else and it didn't really work. So they brought it home and rewrote much of it. It's a wildfly application, a bunch of different clusters for different parts. It's all going into a single Postgres backend cluster. At this point it was line 3 on RHEL, because line 4 was a little bit too new. Bare metal hardware running SSD. Okay, nothing strange for those of us here. We had a little bit of the disaster scenario was we had a primary replicating to a secondary, then back into the primary data center, and also a remote data center very far away. This is all like vanilla stuff for those of you who are used to doing Postgres deployment. Nothing strange. Standard Postgres streaming replication, standard Hibernate application in Wildfly, things like that. And of course, everybody when doing these things are worried about performance. It needs to run fast enough, and of course, nobody ran any full-scale performance tests. Because it's kind of hard to get a couple million people up there to do a performance test for you. And a lot of things were tested, but not enough. Let's put it like that. But we didn't care about it, so we had a lot of monitoring on it. And in general, it worked out very well. Typically, the backend servers running Postgres were something at like 15 to 20% load-in. There were 48 core boxes with 32 gigs of RAM, so it's really like nothing massive. Decent boxes, but nothing massive. We had very fast response times. We had lots of interesting bottlenecks in different parts of the system, unrelated to the backend, unrelated to Postgres, like accidentally downgrading the internet capacity 1 week too early, before the elections instead of a week after the elections. Big interesting thing happened. There were two noteworthy events that I figured I'd mention to you guys. One of them is the concept of unintentional serializing. Really interesting. The scanning interface that scanned these missed ballots, it used homemade sequences. A table with a column in that was updated by +1 all the time. This was done for the scanning. They had a really nice system whereby if scanning went too slow, they could very rapidly deploy new nodes doing more scanning, or OCRing on these nodes. But what happened here was every new node they deployed, the slower the system went, because you had more people blocking on this one node. The way to do that is obviously use real sequences. In this case, it turned out they didn't even use the result value anyway, so we ended up being able to just remove it. Tracked it down using PG logs. We did actually replace it with a sequence, but for the next year, it's been completely removed because it's never used. The other one was the classics of missing index. So one very central table that wasn't very used early, but towards night, about 11 at night, started being used heavily. A few thousand queries a second with simple joins. It performed very well until the votes started getting into the hundreds of thousands or the millions of votes coming in. And then something like this happened. That's the CPU usage of the server. You'll notice the blue is the actual CPU usage. It got up to about 47 out of the 48 cores running flat out before we managed to get the problem fixed. Notice by general system load, track down with PG stat statements, thank you Kodegen, he's not here. And PG stat user tables, fixed with create index concurrently. One of the more interesting points, this graph came out of it. That's the temperature sensors. Missing indexes makes the data center hot. Now in conclusion, democracy for Postgres. Thank you.
Okay, Magnus, nice, very nice. I thought you had a great sense of humor. I love the graphics. I think those were a helpful way to set it up. It was really clear, and I actually found it quite interesting. I think net, I have no critical tweets to make.
Yeah, I'm going to share that. I have no critical tweets either. That was very clear and concise, and I like your storytelling format, and I love that little tidbit at the end about the heat in the data center, because I don't think most people even would think of that, so it's a nice informative takeaway. Thank you.
Terradatum. Hello, everybody.
Good afternoon.
My name is Richard Bellamy. I'm with Terradatum, and we are a small, what I call a boutique real estate data analytics company. And basically, I don't have any pretty slides, and I don't do presentations very often, so you'll have to forgive me if I stumble over my words like I just did. Problem we were solving is we are on Oracle. That's a problem. We needed somewhere to go. We found PPAS and EDB, and we have a legacy J2EE application that has no tests. So how are we going to solve that problem? Well, we need to be able to run our application on top of both Oracle and PPAS, so we can do side-by-side regression. So in Oracle, they have this wonderful little tool called JPublisher. And if you're not familiar with JPublisher, basically what it does is it takes your Oracle objects and turns them into Java code so that you can access your database through JDBC and get access to those objects. So what you end up with is something like this, where basically you set up your connection, you tell it what you're expecting to get back, which is a child table. You execute it, and then you get it back in object-oriented Java. And then, of course, you can hydrate and dehydrate this. This is a very, very primitive object relational map, basically. EDB, on the other hand, is pure Java if you want to talk to your objects. Actually, what I mean is pure JDBC. So you set up your connection, you tell it what you're expecting to get, which is something known as a weak reference. So it's not strongly typed. And when you get it back, you have to know what your index values are for accessing the various elements of the objects. So what we did is we built a code generator and an abstraction layer that allows you to switch your connections between Oracle and PPAS and access your data using basically using object-oriented Java. So you set up your connection, you tell it what type of object is going to be returning, you execute it, and then you use an analog to JDBC, but you tell it what type you're going to be hydrating. And now you're accessing all of the object's elements in a object-oriented fashion. Now, you might be asking yourself, so what? Well, when you've got a 13-year-old application that is the core of your business, and it was built on top of Oracle objects with Java, you don't have a choice. You have to be able to replace your data access layer without having to rewrite things in a completely different model. Furthermore, if you're thinking that you're going to just take the JDBC drivers that would be targeting PPAS and use JPA or InHibernate or any of the other object relational mappers that are available to you, it just flat out doesn't work. For instance, Eclipse Link has an Oracle extension that allows you to talk to Oracle objects, but that Oracle extension does not translate into PPAS. So if you have any kind of object relational mapper on top of an Oracle object system, and you want to be able to migrate to PPAS, you have to use something like this. Thank you very much.
Judges.
So first off, that's a fantastic product. Second of all, somehow in 5 minutes you completely stepped through code and explained it very well, and that was absolutely remarkable. Thank you.
Yeah, Richard, I agree. Nice. I think you did a really good job explaining the solution to a pretty complex problem really efficiently. So,
Thank you.
Good job.
And if anybody wants access to the
Hi, I'm Nick, and I'm originally from Russia, and Magnus talked about democracy in Postgres. I'm going to talk about quite opposite in many senses. Postgres in Russia is growing very fast, and I believe that many of you don't like what's going on in the field of politics, but I'm going to encourage you to see Russia in a different angle. I mean, tech stuff and special development. So I already doing meetups in Moscow already 10 years, participating in several countries as a meeting member, and many of the US guys from Postgres community and Sweden guys as well came to talk in our conferences. So, 2 years ago, I launched our meetup group on meetup.com platform, and it's already 1,200 something, and it's approaching this quarter in San Francisco. And we have 2,000 members in Facebook, all in Russia. So, a lot of events, a lot of interesting, and I observe how interested is increasing. A lot of new users who started to use Postgres like a couple of years ago. And many of them have experience in other databases, first of all MySQL and Oracle. And I encourage everybody to think about submitting talks to one of our three conferences in Moscow and St. Petersburg. And ILOT conference this year is expecting 2,500 people, but it's not only about Postgres, but we'll have a specific Postgres section consisting of 15 talks. And what is happening? Yeah, actually, this March, government released, so Postgres Pro distribution was included to official registry of Russian software. Postgres Pro is open source distribution of Postgres with some additions from Russian hackers. One of them is sitting there. So, I mean Alexander. So it's interesting because actually it's like a community, but for government entities it's like almost must have, because if they want to do something else like Oracle, they need to prove that they need it, and Postgres is not enough. Oracle reaction was very fine. I translated this document and posted it to Magnus. Some of you probably saw it. It's a very interesting document mentioning Postgres disadvantages compared to Oracle, and this is like helping two companies to defend Oracle from open source solutions. So it's fine. And actually people do understand that Postgres is very good alternative. And even before that, what happened with the government section, commercial companies started to move from Oracle as well. For example, Yandex is like leading company in Russia, it's like Russian Google, and they decided to migrate a lot of their project completely 2 years ago, and it's a very good case. It was presented in the Potala this year, and the video is available. And but Avita is another case. It's like Craigslist, and the biggest in Europe. Also building Postgres from scratch, I mean Novick here. And recently, Telecom finally announced that they're in the process of migration from Oracle for e-government things. It's like services helping people to get services from government, insurance, and so on. So a lot of interesting things happen in Russia, and I encourage you to think about it in a positive way, not only political stuff. So follow me on my Twitter. I posted my news related to Postgres in blog languages. Thank you.
Thank you, Nikolay. I think that's actually a great example of how contributing to Postgres is not always just about the code. There's lots of people around the world that work on advocacy, organize meetups, get-togethers, conferences, and I encourage anyone to get involved if they can, because they can be great fun and tremendously rewarding activities. Ed.
Yeah, Nick, great job. I love that you went non-standard with the presentation. That was really, really interesting, and glad to see the progress that you're making. And glad that you're encouraging people to join in.
Thank you very much. That was very fascinating. It's always interesting to learn about how the rest of the world does things in tech, and specifically the state of Postgres in Russia. Thank you.
Thank you. Right, so that's the last of our speakers for today. Whilst the rest of us are probably going to go off and get a coffee now, we're going to lock our two judges away. They're going to deliberate for a while, and then we'll get the announcement, I guess, from you, Ed? In the closing
yeah,
session?
I'm not sure. Sure. I guess I don't know. We'll figure it
From
out.
somebody in the closing session, we'll announce the winner. So thank you very much to all our speakers. Let's have a round of applause for that.